Welcome back to the deep dive. Today we're taking you behind the curtain to look at, well, the invisible, highly technical backbone of modern live broadcasting.
Yeah, because when you watch a massive stadium concert or, a global sports event on TV, the video and audio arrive perfectly synced. It really feels like magic.
Right, but step into the production booth,
hmm
and that illusion just vanishes into a terrifying logistical nightmare of cables, raw data, and feeds.
Exactly. And our mission today is to decode a single dense technical spec sheet from HDTV Supply to see how that chaos is actually managed. We are looking at a compact device with a seriously intimidating name.
The AJA Dante-12GAM 12G-SDI / Dante 32 channel embedder disembedder. I think I got that.
You did, yeah. And at roughly $2,300, we want to figure out how this single metal box solves massive logistical hurdles in audio-video production.
Okay, let's unpack this. Because to understand why this hardware even exists, we first need to look at the massive traffic jam of data happening during a live broadcast.
Right, so in a major broadcast, you're not just sending a picture and a single sound file. You are managing dozens of isolated digital audio tracks simultaneously.
Like commentary, crowd noise, reverie mics, all that stuff.
Yes, all of it at once. And the Dante-12GAM acts as a critical traffic cop. It handles a high-speed, heavy-duty video signal that's the 12G-SDI part.
Okay.
And while that massive video file is passing through, the device can either embed or extract up to 16 channels of Dante network audio in each direction.
Wait, so if I'm understanding this correctly, it's managing 32 total channels of audio over IP, or AOIP, meaning audio sent over a standard computer network, all at the exact same time.
Yes, exactly 32 channels.
It makes me think of like a hyper-efficient UN translator, but instead of just translating languages, it's taking 32 separate audio translations and flawlessly typing them out into the margins of a massive, fast-moving video textbook.
I really like that analogy.
It's doing it without covering up any of the pictures, right?
Yeah, that visual captures the mechanism perfectly. It's weaving standard network audio packets directly into the blank spaces of a professional video stream.
Wow.
And what's crucial is how it anticipates a studio's future needs without forcing an expensive hardware replacement down the line.
Oh, I saw that in the specs. It says you can double the capacity from 32 channels to 64 just by buying an optional software license and plugging in an SFP module.
Which is basically a little hot swappable adapter.
Right, that lets engineers choose between sending the signal over fiber optic glass or traditional copper wire. But wait.
Yeah.
You have to buy a software license to unlock hardware you already physically own?
Yeah, I know it sounds annoying, but it highlights a massive trend in broadcast gear. Manufacturers are building high-capacity hardware, but locking the upper limits behind software keys.
So they just sell you the box and kind of nickel and dime you later?
Well, it actually gives production companies a lower barrier to entry. It lets them scale up instantly only when a bigger gig actually demands it.
Okay, that makes sense.
And speaking of clever problem solving, this device also includes an internal SDI signal generator.
Which means what exactly?
It means it can actually transmit Dante audio over a video cable, even when there's no actual video source plugged into it.
Here's where it gets really interesting. I have to push back on that.
Go for it.
Isn't creating a fake, ghost video signal just to transport audio a bit of a clunky workaround? If you just want to send audio down the hall, why not just use a standard audio cable?
Well, it sounds strange until you look at how these massive broadcast facilities are physically built. Most stadiums and studios are already miles deep in existing SDI video cables.
Right. They've got cables in the walls everywhere.
Exactly. So if an engineer suddenly needs to route pure audio to a remote room, laying new audio cable takes a lot of time and money.
Ah, I see.
So generating a ghost video signal lets them piggyback that audio onto the video infrastructure that's already sitting right there. It's a brilliant instant failsafe.
Huh. So if the ability to generate a ghost signal proves that we're actively trying to adapt old video infrastructure just to move audio around, doesn't that suggest that traditional physical audio cable is, on its way out entirely?
If we connect this to the bigger picture, absolutely. This single spec sheet reflects a massive industry shift away from dedicated physical cables and toward network-based media.
So everything is moving to the network.
Yeah, the industry is rapidly adopting standards like AES-67 and SMPTE ST21 and 30.
Let me guess more alphabet soup that basically means treating audio and video like emails on a corporate server.
You nailed it. It's turning every pixel and sound wave into standardized data packets moving across an IT network.
That is wild.
So the next time you enjoy a flawlessly produced live event, just remember it's likely being held together by compact, upgradable network bridges exactly like this one.
Which leaves us with something pretty wild to think about. I mean, as the tangled mess of copper wires vanishes and live broadcasting relies on the exact same network logic as your office Wi-Fi. What happens to the vulnerability of a live show? I mean, the illusion of flawless magic on your TV is incredible. But when your entire stadium broadcast is just data packets on an IT network, the definition of a broadcast crash takes on a whole new, terrifying meaning.